right, so we're the motion presenter group, and I'll start off with introducing ourselves. I'm Esteban.
I'm Howard.
I'm Sergio. Danny.
And how about you give a flick of the wrist?
Alright, so here's our PCB board design, and starting with the right side over there is the power, all the power components, and then here in the middle are the debug pins, and then here we have all the sensors, and then all the way on this left side we have the PSOC for BLE, and that's how we organize it.
Alright, so here's our enclosure. We have the top open for button pressing. Well, for now at least, isn't going to be the final enclosure because we're going to shrink our board. But essentially it's going to fit the battery in the board, and it's going to have like a strap for now that will strap it to your hand. And for communication, we have a gyroscope, magnetometer, and accelerometer connected to the PSOC via I2C. And then we have our device, which can connect to any BLE device and essentially control any BLE device. Yeah.
It's our first prototype.
Looks pretty damn good.
So for those that don't know too much about the sensors, we're using the accelerometer, gyroscope, and magnetometer. So the way the accelerometer and gyroscope work is that they have a buffer. And the watermark shown in that bullet up above is basically the length of the buffer that you want to pull the information from those sensors. So right below we also have the conversions for these bits of raw data. So the accelerometer gives you 12 bits and you divide by the range, and 2 to the power of 10 because the first bit is the sign and the second bit is basically reserving the first half of the rest of the bits for the positive numbers and the other half for the negative. And then 1G converts to acceleration by multiplying by 9.81. So for the gyroscope, same idea, you divide by 2 bits less, and then you also divide by 1,000 because it gives it in milladegrees per second. And for the magnetometer, it's the same idea as well.
Alright, so we were having a lot of issue with troubleshooting in I2C. So as you can see on the right, this is what it's supposed to look like, and it does. So it's working pretty well right now. But before we were having a lot of issue with the interrupts. A lot of the interrupts are kind of interfering with each other. I don't have a previous example where the accelerometer is actually sampling slightly faster than the gyroscope. They're both at 800 megahertz, or sorry, 800 hertz. And the accelerometer was sending the interrupt about 190 nanoseconds faster than the gyroscope. So eventually you'll see some overlap, like around right here. And we were having this issue where the interrupt service routine was triggering twice. We fixed it and weren't able to re-break it, so we couldn't get a good picture of that. And this probably took the longest because it was a... How did we fix it?
Yeah.
The way we were getting rid of or resetting the interrupt, we were reading the status buffer, or not the status buffer, the status register, and also reading or extracting the information from the buffer. So both of them actually got rid of the interrupt. So by removing the first, reading the register for the sensor, it wouldn't trigger twice during the interrupt.
We should tell them, what does reading the sensor do?
Oh, I'm sorry.
Yeah.
When you read the sensor data, it collects all the samples that are collected into the FIFO buffer and extracting into an array.
Okay. They did a software timing, or you did it?
Oh no, this is all done through the actual sensors. They have internal interrupts
They
that.
give an interrupt and you prioritize the interrupts to time it out of the microcontroller.
Yeah, exactly. So actually, all the gaps in between, like this is all the data that's being sent or collected. All the gaps in between, the PSOC actually goes into sleep mode. So, and we have a video of real-time data that's being collected and plotted on MATLAB.
Full screen.
So the bottom is the magnetometer, the gyroscope, and the accelerometer. So we were able to borrow a magnet from, what are they called, the Eureka people downstairs, and we were able to kind of mess around with the magnetometer with that. We should really get magnets for the lab because we were struggling for a while trying to figure out what we can use to detect the magnetic field.
There's a bunch of speakers.
Do you rewind?
Like disassembled speakers in the lab. They have magnets in the back too.
Oh yeah, we tried that too, but we didn't have the magnetometer working at the time, so we were thinking that was the issue. But then we just managed to get it working as soon as we got the magnet. So
Why do you need the accelerometer, gyroscope, and magnetometer? Explain what complementary information you expect from them.
okay, so the accelerometer gives you acceleration or linear acceleration, while the gyroscope gives you angular acceleration. And the magnetometer, you use both the accelerometer and the gyroscope for inertial detection, but there is a lot of drift because there's a lot of error with, I guess it's not consistent over time. So what the magnetometer does, it kind of keeps track of the drift, so it's able to correct it. And,
Magnetometer?
oh, that was the magnetometer. It's just to make sure to correct any drift between the data of the two previous sensors, the accelerometer and gyroscope.
So here are our power calculations, and so as you can see, the gyroscope takes a lot more than the other two sensors, but the thing that takes up the most current is the BLE when it's transmitting, and that's 15.6 milliamps. And yeah, you can see the power on that side for when it's in active mode and when it's in sleep mode. And then here is the calculation for how many hours we would get in active mode on top and then sleep mode on bottom. And the reason there isn't that much of a difference is that the BLE is still transmitting with this calculation, but with it off and in sleep mode, it will last for 38.5 hours in standby.
There's something that guys do that.
Yeah, that doesn't. Something about those last two don't look right.
Yeah, I mean, somebody you
which
can think how long this accelerometer on, right?
Which one?
How many times do you sample? Well, we go on all the time.
Oh, I don't think we didn't take sleep mode into consideration, right?
Yeah, you should have sleep mode if on the bottom, because 5.2 hours, 5.7, that's not a huge difference. One, all the sensors are off and the thing is asleep. It should last a lot longer than. I mean, BLE is meant to run for a year in a coin cell, right?
Yeah.
You guys have a pretty beefy
So this
LiPo.
kind of calculation is tricky. You have to sort of think logically through it, right? When you take in the time when it's in the sleeping.
Yeah.
Then it could start, but there's fine-tuning.
And then here's our bill of materials. So I listed the main components, and I've also listed how much it would cost if we bought 1, 10, and 100. So under miscellaneous, that would include PCB fabrication, the battery components, and the printed case as well.
Going the wrong way.
Start over.
Obviously, the Tomato getting confused.
Maybe just use a laptop.
No, we're getting it. It takes practice, you know?
Is there a training video you guys have to use this thing?
All right. So in terms of hardware, we're actually pretty ahead because all the device actually does work. All we're doing right now is trying to make it a lot smaller. So we actually plan on trying to get hopefully the final board to be 4 layers and 2-sided, so it's as small as possible. Maybe use a smaller battery. The firmware aspect of it, we mostly just have the drivers for the sensors, and we still haven't really implemented any complex algorithms. In terms of the software, we don't really have, doesn't seem right. For the software, we intend to use it for just choosing the different devices. So we're actually going to make a phone app that is pretty much going to make it so that you can select which device you want to connect to, because there's no way of actually doing it through the actual physical device. And the casing is pretty much on set, same as the hardware. So as soon as we have the PCB design, then we can actually make the casing within a day. And testing, that's going to take the longest, because no matter how much you think it's complete, there's always going to be issues, and it's always going to extend to the very end. And in terms of marketing, I want to say 10%, because we didn't realize that we can communicate this device to multiple Bluetooth devices, so we might have some pretty good ideas in terms of what we can do for marketing with this. Yeah, I would say we're pretty good on track. Yeah. Push the button.